Probability. Theoretical probability. Example 1. This box contains 12 balls of the same shape. 4 of them are white, 3 are blue, and 5 are red. If a ball is drawn randomly, the probability of getting a white ball is the number of white balls divided by the total number of balls, which is equal to 4 over 12, or 1/3. The probability of getting a blue ball is equal to 3 over 12, or 1/4. The probability of getting a red ball is equal to 5 over 12. The probability of getting a black ball is null because it is impossible to find a black ball inside the box. Finally, the probability of getting a white or blue or red ball is equal to 12 over 12, or 1. We define the probability as the ratio of the number of requested outcomes to the total number of outcomes. Important remarks. 1. The sample space is the set of all possible outcomes. In our example, the set of white, blue, and red. 2. The sum of probabilities of all possible events equals 1. In our example, 4 over 12 plus 3 over 12 plus 5 over 12 equals 1. 3. The probability of the sure event equals 1. In our example, the probability of getting a white or blue or red ball equals 1. 4. The probability of the impossible event equals 0. In our example, the probability of getting a black ball equals 0. Other examples. Die rolling. A die has 6 faces. Its sample space is as shown. The set of numbers 1, 2, 3, 4, 5, and 6. For one roll of a die, the probability of the appearance of the number 4 equals 1 over 6. The probability of the appearance of a number less than 5 equals 4 over 6 equals 2 over 3. The probability of the appearance of an odd number equals 3 over 6 equals half. The probability of the appearance of a number less than 10 equals 6 over 6 equals 1. Finally, the probability of the appearance of a number greater than 6 is null. Numbered cards. If a card is drawn randomly from a pile of 20 cards numbered from 1 to 20, the probability of getting a number divisible by 5 is 4 over 20, equals 1 over 5. The probability of getting a prime number is 8 over 20, or 2 over 5. By yourself, calculate the probability that the drawn card carries a number divisible by 5, a number greater or equal to 20, and a perfect square number. Experimental probability. Coin tossing. A coin has 2 faces. Its sample space is as shown. The set of head and tail. For a single toss of a coin, the probability of head appears equals the probability of tail appears, half or 50%. Coin tossing experiment. If we toss the coin 30 times, as an example, the following tally table is generated. 12 times head appears, and 18 times tail appears. The probability of scoring heads in 30 trials equals 12 over 30 equals 2 over 5, while the probability of scoring tails in 30 trials equals 18 over 30 equals 3 over 5. Die rolling experiment. 1. Roll a die 60 times. 2. Record the outcomes. As an example, the following tally table is generated. 3. The tally table is converted to the next frequency table. 4. The probability of rolling a 3 in these 60 trials is 17 over 60. Can you deduce the probability of rolling a 5 in these 60 trials?